Alright, our second example. The word problem is the population of a town is declining at a rate of 6%. If the current population is 12,426 people, predicted population in 5 and 10 years, annually and continuously. Alright, so we're going to do the annually part first. So it says that it's declining at a rate of 6%. So our rate is negative 6% because it's declining. But again, when we're using the formula or when you're making the formula, it's always going to be the decimal value. So negative 0.06. So again, all I did was move the decimal place 2 times, 1, 2 to the left. Now, when we're doing annually, it's the other formula, n equal n sub 0 times 1 plus r to the power of t. So all we do is plug in the values and set up our formula. So n equals n sub 0 is the amount of given in the problem. So the current population is 12,426. So that's what we're going to put in place of n sub 0. 12,426 times 1 plus r, which is the rate that we found, negative 0.06 to the t power, time. So again, here is parenthesis negative. So again, I did that because it was the declining rate, so negative, and 1 is a positive number. So what it means is that it's 1 minus 0.06. So if I were to simplify this, so 12,426, so 1 plus negative 0.06 is going to be 0.94 to the power of time, or t. So again, when it's 1 plus negative 0.06 is basically 1 minus 0.06, which is basically 0.94. Alright, now if it asks you predicted population in 5 years, so basically t is 5 years. So what it means is just n equal 12,426 times 0.94, that's how I got it from here, to the power of 5. Now if I ask you predicted population in 10 years, t is 10 years now. So then the setup, or the model, is n equals 12,426 times 0.94 to the 10th power, or the power of 10. So those will be our two models, our two formulas for annually at a rate of negative 0.06 or negative 6% for 5 years and 10 years. So these two models would be the ones you would use for annually at a negative 6% rate for 5 years and 10 years. Again, we're using the same problem. Now we're going to talk about continuously. So instead of the R value, we're going to use the K value, the K letter, and it's still the same, negative 6% because it's declining. So basically K is equal to negative 0.06. Always use a decimal when you're making a formula, especially when you're going to type this into the calculator. So when it's using continuously, then the formula is n equal n sub 0 times the e function to the power of kt. So all we're doing is going to fill in n sub 0 and k. So n equals 12,426 times the e function to the power of negative 0.06 times t, close parenthesis. So again, n is what we're looking for because it asks you predict the population, equal 12,426 times the e function to the power of negative 0.06 t, or times t. Now it asks you predict the population 5 and 10 years. So all I have to do is fill in the t value. So if t is 5 years, then our model, or also known as formula, n equals 12,426 times the e function to the power of negative 0.06 times, that's times 5, close parenthesis. Now if it asks you for 10 years, so t equals 10 years, then our new model or formula will be n equals 12,426 times the e function to the power of negative 0.06 times, again it's times 10. So that's how you would set it up. Now don't mix up with the decimal point and the multiplication point here. So the model or formula for when it's continuous at negative 6% for 5 years, this is the one you would use. If it's continuous at negative 6% for 10 years, this is the one you would use. You would use these setups in the calculator, and then whatever answer you get, that's the answer for the prediction of the population. So again, focus on setting up the models or formulas correctly in order to get the answer correctly from the calculator. So again, this is the formula for continuous at a rate of 6%, or the decimal value, negative 0.06.